Now comes the physical properties and chemical properties. Here under physical property, melting point and boiling point. Here you see the iodo will have boiling point more when compared with bromo. Again, bromine will have more when compared with chloro. Okay, the boiling point and melting point that gets a higher depends on the isomer that is attached. So this is because of the symmetry. Here the symmetry will lead to the close packing of a molecule in a crystal lattice. Right? So that leads to give a strong attractive force. So it requires more energy for the breaking of a compound so that the melting will be slower. Right? Here the example para dihalobenzene is more when compared with orthodichlorobenzene, which is more when compared with the meta-dichlorobenzene. Okay. Now comes the solubility. Here in solubility, the haloarenes are insoluble in water because they won't form any hydrogen bond with water, and it is soluble in organic solvents. Now comes the density. Here in density, haloarenes are heavier when compared with the water. So the density seems to be iodobenzene is more denser when compared with the bromobenzene. When compared with chlorobenzene, this bromobenzene will be more. Now comes chemical properties. Here in chemical properties, first comes aromatic nucleophilic substitution reaction. Here also the same mechanism we have to follow. Only thing is that in the place of alkyl, we are replacing with this aryl group. So aryl அப்படின்றது benzene ring போடுறோம். Okay. So now, first example, chlorobenzene along with this NaOH. This NaCl gets removed so that we get the product as a phenol. The name of the reaction is known as Dow's process. Okay, this is one of the naming reaction. Again, with chlorobenzene, the presence of ammonia, it leads to form aniline. With chlorobenzene, it forms phenyl cyanide. Okay, now comes the wood splitting reaction. That is a reaction with metals. So with chlorobenzene, with chloroethane, reacts with sodium in the presence of dry ether. On heating, we get ethyl benzene. Now, fitting reaction. Here in fitting reaction, chlorobenzene, sodium, and then this we have to take two haloarene. Presence of dry ether. On heating, we get the product as biphenyl. Now comes electrophilic substitution reaction. Here in electrophilic substitution reaction, uh, electrophile will get attached to the benzene ring, right? Actually, this takes place by halogenation, nitration, sulfonation, and then Friedel-Crafts alkylation. See, with halogenation, the halogen group attached, that is in the presence of FeCl3, and the product is dichlorobenzene and then dichlorobenzene. Here the major and then minor product is possible. Okay. Here with nitration, the same chloronitrobenzene, and then here you see sorry, orthonitrobenzene and then para-nitrobenzene. The position of the nitro group will be attached as like this. Next comes the sulfonation. Here orthochlorosulfonic acid. It is benzene sulfonic acid, parachlorobenzene sulfonic acid. Then in Friedel-Crafts alkylation, AlCl3, anhydrous AlCl3 that leads to form, that is a benzene ring attached with a methyl group that is said to be toluene, and a chlorine group attached here is a major and the minor product given over here. Now comes toluene. Here in toluene, the reduction, it is a reduction reaction. First, the haloarenes reacts with hydrogen. It is a reduction reaction, no? Which means it takes place in the presence of nickel aluminum alloy. So alloy means it is a mixture of two or more metal. With NaOH, it leads to form benzene with the elimination of HCl. Now with Grignard reagent, it forms phenyl magnesium chloride, the presence of tetrahydrofluoride. Now comes uses of chlorobenzene. Here in uses, it is used as a pesticide like a DDT. It is used as a high boiling solvent in organic synthesis, and also it acts as a fiber spelling agent in textile processing. So textile வந்து பார்த்தீங்கன்னா இந்த ஃபைபர்ஸை நல்லா உப்ப வச்சு அதுக்கு இந்த குளோரோபென்சின் காம்பவுண்ட் யூஸ் பண்ணுவாங்க. ஸ்வெல்லிங் ப்ராப்பர்ட்டிக்கு யூஸ் பண்ணுவாங்க. Now comes polyhalogen compounds. Here in polyhalogen compounds, the carbon compounds will contain more than one halogen group. That is polyhalogen compounds. Now it is classified as gem dihalide, and then the preparation is given. Here, the gem dihalide is ethylene dichloride. There is a dichloro, two chlorine is there, so that we can name it as ethylene chloride, or else simply 1,1 dichloroethane. Okay. Then here you see the vinyl group, that is ethylene dichloride or else ethylene chloride simply. Now comes preparation. Here in preparation, gem dihalide, this ethylene dichloride prepared by treating with PCl5. Here acetaldehyde on treatment with PCl5 we get ethylene dichloride. What happens is that the chlorine group, 2 chlorine from this PCl5 will attach to this, and this oxygen will attach to this PCl3, so that we get UOCl. Okay. Now on adding with the hydrogen chloride to form acetylene. Okay. Again, this dihalide. Here you see ethylene along with chlorine we get ethylene dichloride, and with glycol we get the product as dichloride. The properties like it is a sweet smelling because aromatic compounds are pleasant smelling compound, and it is having a sweet smelling and then colorless liquid that has relatively high boiling points. Okay. And also the boiling points of this ethylene chloride is less when compared with the dichloride. Now I will move on to chemical properties. Here in chemical properties, the first one will be hydrolysis with aqueous overhead. Here on hydrolysis, it is simply addition of water molecule. That the reaction first starts with the reagent ethylene dichloride in the presence of KOH. HCl gets removed, get the product is acetaldehyde. Okay. With alcoholic KOH, that is on dehydrohalogenation,